displacement with respect to time. Okay, so what is given to me? Displacement with respect to time. Is that right? At what time was the at what times was the point at its starting position? What does that mean? At what times were the particle at the starting position? What does starting position mean? The displacement equal to 0. So what is it asking? It is asking that when was the displacement 0? At what times was the displacement 0? So what will I do? I'll put 0 for displacement. Is that right? Take it. Okay, so I can take t square common. I can take t square common, and this will be how much? T square minus 16t plus 64 divided by 4. Is that right? Is that right? Alright, can I factorize this? So this will be 0 is equal to t square by 4, and then can I factorize this? This is I guess 8, t minus 8 ka square, that is t minus 8 ka square. Is that clear? Okay, so what do I get? I get either t is equal to 0 or t is equal to 8. Clear? Either this is 0, that means t is equal to 0, or t minus 8 square is 0, that means t is equal to 8. Is that clear? So the times at which it is at its mean position is what? 0 or 8 second. Is that clear? Okay, at what times is its velocity equal to 0? How do we find that out? Differentiate it. Okay, so if the displacement is given to me, how do I find the velocity? I differentiate it. I find ds by dt. Is that right? Correct? Okay, so what will be ds by dt? Tell me. T cube minus 12t square plus 32t. Okay, I hope everyone can do this. Alright, ds by dt will be, so t to the power n, all you need to do is differentiate x to the power n, that is n into x to the power n minus 1. Alright, so this is the velocity. This is the velocity as a function of time. But what is being asked? At what times is the velocity 0? So what should I do? Put 0. Put v is equal to 0, so that will give me, I can take t common, and that will become t square minus 12t plus 32 equal to 0. Can I factorize this? 8 and 4. So t square minus 4t minus 12t plus 32 equal to 0. So this will become 0 is equal to t into, and this becomes t minus 4 into t minus 12. Sorry? Sorry. 8t. So that will be t into t minus 4 into t minus 8. Okay, so either this is 0 or this is 0 or this is 0. That means t can be 0 or 4 second or 8 second. Is that right? Any problem? Excellent. Now go to question number 2. We should breeze through these questions. Very simple questions. So it should not take more than 30 seconds. Done? Alright, so all I need to find the kinetic energy, half mv square. Kinetic energy is half mv square. So do I know the mass? I know the mass. What do I need? I need the velocity. When do I need the velocity? At t is equal to 5 seconds. Is that right? I need the velocity at t is equal to 5 seconds. For that I need to first of all find the velocity as a function of time. Okay, so s is given to me as 1 plus t square. So velocity is ds by dt, and that will be what? 1 plus 2t. Correct? So what is the velocity at 5 seconds? I'll put 5 over here, and that will be 11 centimeter per second. Yes, you should be careful because the displacement is in centimeter. So the velocity after 5 seconds would be 11 centimeter per second. So the kinetic energy would be half into m. What is m? 3 kg, and then 11 centimeters per second is 0.11 meter per second. And I need to make square of this. And the final answer I'll get in SI units, that is joule. Correct? Clear? Okay. Quickly do the third question. Done? So what is required? Find the acceleration when velocity is 0. So first of all, you should find out when is the velocity 0. For that you need to find out what is the velocity. Okay, so what will be the velocity? S is equal to t cube minus 4t square minus 3t. So the velocity will be ds by dt, and that will be 3t square minus 8t minus 3. Correct? Okay. Now when is the velocity 0? The velocity is 0 when this is equal to 0. So how can I factorize that? Minus 90 plus t minus 3. So this will be how much? T minus 3, and then this will be 3t plus 1. So time comes out to be minus 1 by 3. Does not, makes no sense. So time is equal to 3 seconds. Is that clear? So at time is 3, at t is equal to 3 seconds, the velocity is 0. So the question is, find the acceleration when velocity is 0. So I have to find the acceleration when time is 3 seconds. That's it. So for that I need to find the acceleration. So I need to differentiate v. Is that right? To find the acceleration, I'll differentiate v. So when I differentiate v, I'll get 6t minus 8, right? All I need to do is put t is equal to 3 seconds. So I need to find the acceleration at t is equal to 3 seconds. That will be 6 into 3 minus 8, and that is 18 minus 8 is 10 meter per second square. Everything is in meter and it's not given. Okay, whatever is the unit. dv by, so this is v, 60 minus 8. To differentiate t square, you'll get 2t. 3 is a constant, so 60 minus 8 is a constant, t ka 1. ठीक है, clear? Try question number 4. You have done the, ठीक है, do the fourth one also. हो गया, ठीक है, good. If you have done the fifth one, try the sixth one. Okay, check. 4, the answer is 0. Let's see. Okay, find the displacement of the particle when velocity is 0. Find the displacement of the particle when velocity is 0. So for that, first of all, I need to know when is the velocity 0. For that, what do I need? I need the velocity. To find velocity, what do I need? dx by dt. So first of all, I need to convert this equation in terms of x. So what is given to me? T is equal to root x plus 3. So I should first of all find out x as a function of time. So that will be how much? T minus 3 square. Is that right? X is equal to t minus 3 square. Is that right? Alright. Now what do I need to find out? I need to find out dx by dt. So the velocity will be dx by dt. Now I should differentiate t minus 3 whole square. How do I do that? I'll use the chain rule. So this is t minus 3 ka square. So first I'll differentiate with respect to t minus 3. And that will give me 2 into t minus 3. Then I'll differentiate t minus 3 with respect to t. That will give me 1. So that's it. So the velocity is 2 into t minus 3. Is that right? Clear? Okay. So what is asked? When is the velocity 0? So I'll put 0 is equal to 2 into t minus 3. So the velocity is 0 at t is equal to 3 seconds. Is that right? Okay. Now what is the displacement? I'll find the position. So x is equal to 3 minus 3 ka square. So that will give me 0. So when the velocity is 0, the position again becomes 0. So what is the displacement? 0. X is equal to t minus 3 square. So I'm finding the position at x is equal to 3 seconds. So what will I do? I'll put t is equal to 3 seconds. Clear? Huh. Huh. You tell me, is it accelerated or not? The velocity is constant or variable? The velocity is constant or variable? It's variable. So what is acceleration? Is there. Correct? Okay. Try question number 5. So what is required? The distance covered. Yes, you will have to integrate. Now listen, first listen. The question is to find the distance. So dx by dt is equal to v. So dx is equal to v dt. That is all right. But if I integrate, what do I get? I get the integration of dx will give me what? Within the limits it will give me what? The displacement. Is that right? The integration of dx is going to give me displacement. But what is asked? Then what should I do? When is the distance and displacement same? In the same direction. Till the particles are moving in the same direction, they'll have the same distance and displacement. Is that right? Okay. Now v is given to me as 3t square plus 2t plus 1. 3t square plus 2t plus 1. So what does the direction of v give me? The direction of motion. Okay. So if I can assure myself that v is either always positive or always negative, that v does not change its direction, then the distance and displacement will be the same. Is that right? Do you get this? Alright, so till the time velocity is not changing its sign, till that time I can say that the distance and displacement is the same. So I'll find the displacement and then I'll say that the distance is the same. Is that right? So can you tell me that 3t square plus 2t plus 1, will its sign change? Why not? Time to will always be positive, but how can I be sure that 3t square plus 2t plus 1 will always be positive? You're right, you're absolutely right. If I substitute t, everything is positive. So I will always get positive. So in this case, I can assure myself that the distance and displacement will be the same. Is that clear? Find the displacement, that will be equal to the distance. Do that. Yes. In that case, what to do? That's what you need to think. Suppose someone is changing in his direction. I need to find the distance. What should I do? I go from there to there, then I come back from there to here. How do I find the distance? This distance plus this distance. You get that? So you need to break that journey into the points where they are moving in the same direction. Alright, so 5 you could do. Do you have difficulty doing 5? If you have difficulty doing 5, that means you have not practiced integration enough, and which you absolutely must not. You have to do a lot of practice in integration. Alright, so dx, integration of dx is equal to v dt. Do you get that? Take it. So this is going to give me the displacement. So displacement is equal to, what is v? V is equal to 3t square plus 2t plus 1 dt, and I need to integrate that between what interval? 10 seconds from start. So the limit of integration would be from 0 to 10. That's it. Alright, so I integrate 3t square. What would I get? 3 is a constant. T to the power 2, that will become t cube by 3. 2 is a constant. Integration of t will become t square by 2. I hope you are comfortable with this. If not, go and revise. Integration of 1 will be t. Is that clear? ठीक है. So this is t cube plus t square plus 1, but I have to put the limits from 0 to 10. Substitute 10, I'll get 1000 plus 100 plus 1, so that will be 1110 minus 1. I have to put 0 in all of them, so 0 0 and this will be 1. Okay, so this will give me how much? 1109 meter. Is that clear to everyone? Or do you have problems? Huh. So t cube plus t square plus 1. I think this is where? Why shouldn't I put the limits? Why shouldn't I put the limits? I'm integrating it within the limits of 0 to 10. So why shouldn't I put the limits? Oh, so this is t. Oh, sorry. So this is t. My bad. This is t. So this will give me 1000 plus 100 plus 10. So that will be 1110. Yes, you are right. Minus 0 0 0. So this will become 0. Yeah, you are right. Alright, but it does not mean I have not put the limits. I've obviously put the limits. Alright, is that clear? Okay. Now try question number 6. Without putting the limits, you'll have a plus c. You have a constant of integration. How do you solve that? You'll have to find the constant of integration, right? So either you put a value, choose a value of t for which you know s, then you write then you can from there you can find the constant of integration. Otherwise use definite integral. Okay, and obviously this is the thing you should do, because it is asked between t is equal to 0 to t is equal to 10 second. Okay, try question number 6. What is required? The distance covered. Do you get this? What is required? The distance covered. Alright. When I integrate, what do I get? Displacement. So I need to be sure that the distance and displacement are the same. For that, what should I know? That the velocity is not changing the direction. Alright, but you look at the equation, 9t square minus 8t. Is the velocity changing direction? Is the velocity changing direction? Where? Where is the velocity changing direction? Not changing direction. 9t square minus 8t. Right. So when I'm talking about changing the direction, what does that mean? Does the sign of velocity change or not? Does the sign of velocity change or not? Does it or does it not? It does not? Okay, let's see. Put t is equal to 0. What do you get? Alright. Okay, let put t is equal to 1. What do you get? 1. Okay, at t is equal to 1, the velocity is positive, right? Put t is equal to half. Put t is equal to half. Negative. T is equal to half gives me what? Negative. Right, so the velocity is changing. Do you get this? The velocity is changing. Then what should I do? What should I do? For this, I should know when is the velocity positive, when is the velocity negative. Alright, the way to do it is finding the sign scheme. You'll study this in when you study functions. Okay, but I'll tell you a little bit about sign scheme. Sign scheme means if I'm given a polynomial, I should be able to find out when is it positive, when is it negative. Alright, so what is given to me? V is equal to 9t square minus 8t. Or do you know a little bit about quadratic? Okay, do you know the graph of quadratic? Yeah, it's parabola, but how do you draw that? What is the property of the parabola? Any curve will be a parabola. No, it's not. No. There are certain properties associated with the conic sections, okay, which you'll deal with later. Don't worry, don't worry, don't worry. But what I can do is, I can take a few points and plot it. Can I do that? Okay, first of all, tell me what are the roots of the equation. If this is the quadratic, if I make it equal to 0, what will be the roots? 0 and 0 and 8 by 9. Okay, so if I make 9t square minus 8t equal to 0, I can take t common and that will give me 90 minus 8 equal to 0. So that gives me either t is equal to 0 or 8 by 9. So t is equal to 0, the graph will be at 0. T is equal to 8 by 9, the graph will be at 8 by 9. So this is 0. Let's say this is 8 by 9. So the graph is 0 at these points. Alright. Okay. What I can do is, I can put a value greater than 1. Greater than this root and see if it is positive or negative. Alright. Can you put a value greater than 8 by 9 in this equation? We can choose one. Simplest case, we can choose one. If we choose one, this graph is positive. So this graph is positive. This side of the graph is positive. Alright. Can we choose a number which is less than 1? Sorry, less than 0? Can I choose a number on this side? Okay, excellent. Time cannot be negative. Okay, can I choose a number between these two? Half, put half. When you put half, so when you had put half into it, what did you get? Negative. Alright, so the quadratic would look something like this. So this part I'm not drawing, but if I complete this quadratic function, it will be something like this. Alright, so so between these two, put a value. What do you get? Negative. So this will be negative. Ahead of this, if you put a value, you get positive. This will be positive. So the change in sign, so understand this, the change in sign is always going to happen at the roots. In terms of physics, if we talk about, so this is the VT curve, is that right? So change in sign means what? The direction is reversing. Alright, can the direction reverse without the velocity being 0? It cannot. If you're moving in a straight line, when you have to come back, you have to stop over there, at least momentarily. Is that right? So whatever is the change in velocity, that can only happen when the velocity becomes 0. That will be the junction of the change of velocity. Is that clear? So here the velocity is changing. The velocity is also changing here, but we don't take negative time. Okay, so it goes from positive to negative, then from negative to positive. Is that clear? Okay, but t less than 0 is not relevant in this case. Is that clear? Okay. Now is it clear when is the velocity negative, when is the velocity positive? So velocity is negative here, velocity is positive here. Okay. Now what do I need to find out? I need to find the distance traveled. Okay, the distance traveled, and in what time interval? During the 4th second. It is not at 4 second or up till 4 second. It is during the 4th second. What does during the 4th second mean? Between 3 and 4. I start the stopwatch. The 1st second, what does that mean? The 1st second, it starts from 0 and will go up till 1. So the 1st second is between 0 and 1. The 2nd second is between 1 and 2. So the 4th second is between 3 and 4. So I'm talking about the time interval 3 second 2, 3 is equal to 4 second. That is the fourth second. Is that right? Now where is the fourth second? It will be somewhere here. Let's say this is 3, this is 4. Okay. So I'm talking about the interval of t is equal to 3 to 4. In that in time interval, is the velocity positive or negative, or is it changing? It's positive. So the velocity is not changing. Do you get that? During the time interval of 3 to 4, the velocity is, the direction of velocity is not changing. It is positive. So can I say that the distance and displacement during the 4th second will be the same? Can I say that? So I can also say that whatever I find as the displacement will also be the distance traveled. Is that clear? Clear? Now how do I find the displacement from t is equal to 3 to t equal to 4? I'll have to integrate. Okay, so dx by dt is equal to v. I can write dx is equal to v dt. So this becomes dx is equal to, what is v? V is equal to 9t square minus 8t. So tell me, what will be the limit of integration? 3 to 4. Absolutely. So this I can write as the position at 3 and the position at 4. This will give me the position of 4 minus position of 3. That is the displacement in the 4th second. Is that clear? This will give me the displacement in the 4th second. Integrate this. What do you get? So this will be 9 into t cube by 3, and put the limit from 3 to 4, minus 8 into t square by 2, put the limits 3 to 4. Is that right? So 3 is common, you can take it out. It's constant, you can take it out. So this will be 4 cube. 4 cube means what? 4 cube means 64. So this will be 64 minus 3 cube. So that is 27. Minus 4 will be common. And then I have to put the limits in t square. So that will be 16 minus 9. So what do I get? Finally, what do you get? 83. Is that clear? Do you understand this concept? If displacement is required, no worries. Simply integrate. No second thoughts. But if distance is required, I need to make sure the velocity is not changing. Then I can say that the displacement is distance are the same. Is that clear to everyone? Any problems? Okay. Now, clear? Now, what if I asked you what is the distance traveled from 0 to 4 second? Yes, absolutely. So first we'll find the displacement from 0 to 8 by 9, and then we'll find the displacement from 8 by 9 to 4. Is that clear? How do I find the displacement from 8 by 9 till 8 by 9? I'll integrate. Now can you tell me what this integration, if I integrate v dt in the limit 0 to 8 by 9, should I get positive or negative? Should I get positive or negative? This area is below the t-axis. That means the particle is moving in the negative direction. So what is this displacement? This is negative. What is this displacement? This is positive. So I'll take the mod of this and I'll take the mod of this, and then I'll add them. Is that clear? How do I find the distance? The subtraction of the mod of area. Is that right? So if this is negative area, I'll subtract it. Clear? Any problem? What is the time? Is it 2:30? It's 2:30. How many questions are there left? 3. Let me see if there's anything new. It's almost the same. Okay, so we can take a break at this point. Let's come back in, let's say, half an hour. Have lunch. हाँ? तू वापस आ जाना 15 मिनट में.